Okay, so yesterday we looked at solving systems of equations by graphing, and today we're going to be looking at solving systems of inequalities by graphing. Often in algebra, where you have equations, that is, inequalities cannot be far behind. So, in real life, inequalities are very common. The comparison we make in doing some real life problems in engineering and science and so on, oftentimes, it's not a comparison saying things are equal, but instead saying one is greater than the other, or one is less than or equal to the other. So they are very important as well. So Section 3.2, Solving Systems of Inequalities by Graphing. A little bit of review in solving, and that is graphing a single inequality. We're not talking about a system in this review, but just how do you graph the inequality. So you graph the line that you would have if it were an equation, and that will be a dashed line if you have less than or greater than, and you graph it with a solid line if it's less than or equal or greater than or equal. And then you shade one side of the line. If it's less than or equal, you shade below. If it's greater than or equal, you shade above. So just a quick summary. For less than, you graph it with a dashed line and shade below. For greater than, it's a dashed line and shade above. For less than or equal, use a solid line and shade below. And for greater than or equal, use a solid line and shade above. Okay, so we will use that in solving these systems of inequalities. So our first example, solve the system of inequalities by graphing, and here's our system. Y is less than negative x minus 3, and y is less than or equal to x plus 1. And there will be many solutions to this, as if there's an overlap between those two. So some points satisfy the first one, and some other points, lots of points, satisfy the second one, and those that satisfy both, that is our solution. So let's look at this. We'll for the first one, it's less than, so we're going to use a dashed line to graph this. We'll graph the equation, y equals negative x minus 3. That's what we'll graph, but it'll be a dashed line. So this would be slope-intercept form. So we have negative 3 is the intercept. So we can mark that there. And the slope negative 1. So rise over run is negative 1. We could take negative rise and positive run. I have one each, and it would go right there. And we're going to graph that with a dashed line. So use this ruler. Get it lined up on those points. And now I'll just make a dashed line. Okay. So there's the dashed blue line for that one. And then the other one we'll use red. So that's x plus 1. So slope-intercept form, so 1 is the y-intercept, and then the slope of this is positive 1. So rise over the run, rise of 1, run of 1. We'd have another point right there. Okay, and we'll make this with the red line. everything lined up. Make that a dashed red line. Oh, sorry, this one's a solid red line. Okay, because this is less than or equal, so we make a solid line. Okay. Put some arrows on that. Didn't put the arrows on the blue. Let's do that. And now we need to shade. I didn't shade before. So for the blue line, our first one, okay, and I could, let's just mark this with blue somehow, put some blue beside it. That looks kind of ugly. We'll just remember that's the blue one. Actually, now I'm going to shade it. We can do this. We'll switch to a marker, and we'll shade that like that. Okay, so it's less than. So we shade underneath that dashed line. Okay, we shade that blue. Try to show that the line is dashed, so I don't want to cover it up. Okay, so there is the points that satisfy that. We've shaded them. And then, sticking with the marker, we want to shade below the red line, because this one was the red one, right? So shade it red. Whoops, not good. Went over the line. Okay. Okay, so those are the points that make that one true. And the overlap, okay, where both are shaded, that is our answer. Okay, so this whole area down here, the overlap of both, that's the answer. Those are the points that satisfy both. Let me go back to the red marker, get it. I didn't really get this done quite well enough. That's the red, the blue, same thing. Okay, you get the idea anyway. So the overlap is the solution, okay? Okay, so that's the first one. Let's look at one more example. And so we're going to graph these two. Pretend this is a line again, this first one, and this will be a dashed line because it's greater than. But the y-intercept of that is 1. And then the slope is -1/2. So the rise over the run will make the rise -1, will make the run +2. Okay, to have a negative slope. Either the rise or the run is negative, the other one's positive. So rise of -1, run of +2. I'll make that line. Okay, about right there. And this will be a dashed line. because it is greater than, not greater than or equal. Okay, so that's the line. And this time, I'm going to go ahead and shade above that. It makes a little more sense to do that immediately after we make the line. So we shade above, right, because it's greater than. So here we go. My marker's not really quite wide enough. Okay, so those are the points that make that one true. But we want the points that make both true, right? So we're going to graph the other one and do the overlap. So go back to red. Oh, before I do that, I'm going to shade over this to show that's the one that was blue. Okay, now we go back to red. And this one's, the intercept is -1. Oh, wrong one. And the slope is -3/2. A negative slope, we'll use a negative rise and a positive run. Negative rise of 3 means go down 3 right here. Run of +2 gets us to right there. And we'll make that line. Let's see. All right. There. This one is going to be a solid line because it's less than or equal. And we will put the arrows on it, and we will shade which side of this one? Below it, right? Because it's less than or equal. So we shade below, we shade it in red, and so we're shading all the points that make that one true. And again, the overlap is the region where both are true. And that is, we can point it out right here. This overlap, we could call that the answer. That's the place, that's the region of the Cartesian plane where both of these equations are true. I'm sorry, where both of these inequalities are true. Those x's and y's in that region where the two overlap. Okay, so that's a couple of examples, and the homework's posted on Canvas. So that's all for now.